Now we are going to see how to sort 10 elements using insertion sort. In insertion sort, we'll first consider that the first element is already sorted. So now you can see that in array index 0, the element is already sorted. Now take the second element. Second element is 7.42. Take the second element, compare it with the previous element, which is 2.78. Now comparing both of them, the previous element is smaller than the current element, which is the key element. So there is no swapping. Now, so far we have read two elements, 2.78 and 7.42. Both of them are sorted. Next step, take the third element. Third element is 0.56. Now this is the key element. So take the key element, compare it with the previous item, which is 7.42. As the key element is smaller than the previous item, 7.42, we have to make a swap. Now compare the key element with the previous item, which is 2.78. Comparing key element 0.56 with 2.78, key element is smaller, so we have to make a swap. Now we have traversed 3 items and all the 3 items are sorted. Now let us go for the next item, which is 1.12. Now 1.12 is the key element. Compare the key element with the previous item, which is 7.42. As we compare it, we see that the key element is smaller than the previous element. So let us go for a swap. Now again, key element is smaller than the previous item, which is 2.78. So let us go for a swap. Now the key element is greater than the previous element, so we are not going to make any swap. Now that we have read 4 elements and all the 4 elements are in sorted order. Next, let us take the next element as the key element, which is 1.7. Now 1.17 is the key element. Compare this key element with the previous item, which is 7.42. When we compare it, we see that the key element is a smaller element. So let us go for a swap. Now this key element is smaller than the previous item. So let us go for a swap. Now comparing this key element, the previous element is smaller. So that is it. So we have read 5 elements and all the 5 elements are in sorted order. Now let us go for the sixth element, which is 0.32. So 0.32 is the key element now. Now again, start comparing this key element with the previous item. So this previous item is a greater item, so we'll have to go for a swap. Now again, compare this key element with the previous item. Key element is smaller value, so go for a swap. Now key element, compare it with the previous item. Key element is smaller, so go for a swap. Compare this key element with the previous item and we see that key element is smaller, so go for a swap. Now compare this key element with the previous item. Key element is smaller, so go for a swap. Now we can see that we have read 6 items and all the 6 elements that we have read so far is sorted. Now let us go for the 7th item, which is 6.21. Let us consider this is the key element. Now compare this key element with the previous item. Key element is smaller, so go for a swap. Compare this key element with the previous item. You can see that the previous item is smaller. Key is greater, so there is no need for any more swapping. Now we have read 7 items so far and all the 7 items are in sorted order. Now let us go for the 8th item, which is at index 7. The value is 4.42. So 4.42 is the key element now. Compare 4.42, which is the key element, with the previous item, and we can see that key element is smaller. So go for a swap. Compare this key element with the previous item, and you can see that key element is smaller. So go for a swap. Compare key element with the previous item, and you can see that key element is greater than the previous item. So there is no more swapping. Now let us go for the 9th item. Take it as the key item. So 9th item is 3.14. So compare this key element with the previous item. So you can see that the key element is smaller than the previous item. So go for a swap. Compare this key item with the previous item, and you can see that key item is smaller. So go for a swap. Now again, compare the key item with the previous item, and you can see that key item is smaller. So go for a swap. Again, compare key element with the previous item, and you can see that key item is greater than the previous item. So there is no more need for any swapping in this iteration. So we have read 9 items so far, and all the 9 items are in sorted order. Now let us pick the last item, which is the 10th item. So 7.71 is the 7.71 is the key item. So compare key item with the previous item, and we can see that key item is greater than the previous item. So there is no more swapping required. Now that we have read 10 items, and all the 10 items are in sorted order, and it is sorted using insertion sort. Here we have insertion sort. So we assume that the first item is already sorted. So we are going to take the second item till the last item for sorting. So j is equal to 2 to length till the end, from second item till the end. And as we assume that the first item is already sorted, the second item, from the second item, each item will in turn be the keys. So key is equal to A of j. Now we have a while loop in order to make the shift left side only if I is greater than 0, because we don't have any more items to the left of 1. So when I is greater than 0 and A of I is greater than key, which is when your left item is greater than the key element, only then we are going for this swap. Swap is bringing the left item to the key item. So only in this case we are going for this shift. So this is the insertion sort. Here we are going to analyze the time complexity of insertion sort using operation count. So in order to analyze the time complexity using operation count, we have to identify each executable statement and provide a cost value for each of them. The cost varies for each executable statement. So here we are giving various cost values, which is C1, C2, C3, and all these are constants. Every executable statement may be executed 1 time, 2 times, or it can be n number of times depending on if it is in a loop or not. So what we are going to do is we are going to identify the cost and frequency of each executable statement, multiply them, and finally make a summation and identify what is the order. So here the first statement is a for statement. So the loop runs from 2 to n, so which is n times. Now we have key is equal to A of j. This statement is within the for loop, so it runs n minus 1 time. I is equal to j minus 1, it runs n minus 1 time. We have a while loop within the for loop, so we have summation of j is equal to 2 to n, and then this is the number of times while loop runs, which is tj. We have two statements within the while loop, so they run tj minus 1 time, and this j varies from 2 to n. Again, I is equal to I minus 1 statement runs tj minus 1 time, and j varies from 2 to n. Now this statement lies outside the while loop within the for loop, so this runs n minus 1 time. Now why do we say that the first statement runs n time and the other statements are running n minus 1 time is, we will have one condition check finally where the condition is false. So just this statement runs n times, all the inner statement will run n minus 1 time. Now we are going to analyze two cases, best case and worst case. In best case, we assume best case is the case where all the data is in sorted order. So when the data is in sorted order in insertion sort, you can understand that your for loop runs. So rj will be from second item to the last item. We will be assigning the key I is equal to j minus 1. All these statements are executing. This condition checking also happens. I is greater than 0 and a of I is greater than key. So this condition is also checked every time. But this looping, which we use it for swapping or shifting the data when the key is lesser than the previous item, only happens only when the key is lesser. So we have to ignore these two statements for the best case. So here you can see I have calculated the best case, C1n plus C2n minus 1 plus C3n minus 1 plus C4n minus 1. So this condition checking happens. So C4n minus 1. These two steps we can ignore because this doesn't happen when we are in a best case. And finally C7 into n minus 1. So we just have to solve this equation, solve this expression, and we get n into a constant minus a constant, which is an minus b. So this you can say that it is of the order of n. This is the best case of insertion sort. Next, coming to the worst case of insertion sort. So when we have this worst case, these two statements are also executed, right? So C1n, C2n minus 1, C3n minus 1, C4n minus 1. So this will be running n into n plus 1 by 2 times, because you will have n items. If there are n items, this is sum of n natural numbers. If I have 5 items, it is going to happen 5 times, 4 times, 3 times, 2 times, 1 times, right? So this comparison and swapping is happening n into n plus 1 times. So instead of n, we are going to substitute n into n plus 1 by 2. This is an inner statement, inner to your while statement, right? So instead of n, we are going to use n minus 1. That's all. So n into n minus 1 by 2. Similarly, this statement, these two inner statements are going to happen for n into n minus 1 by 2 times. Plus this is the final statement, C7 into n minus 1. So when you solve it, you will be getting this order, an square plus bn plus c, which is of the order of n square. So the worst case of insertion sort is n squared.